Alright, today we're going to talk about solving radical equations. Now I want you to recall that solving equations requires isolation of the variable. Now, equations that contain variables inside of the radical require algebra as well. Now, there are two types of situations that we could come across that we'll discuss in this lesson. The first type is the main one. You try to get this one first. The first one is when you have a radical, one radical. So in the equation 5, the square root of 5 minus x minus 3 equals 0. That's the first type we'll cover. It contains a radical and a constant term. An equal sign. Alright? So when there's one radical, there's things that we need to do to solve. Then another type is when we have square root of x squared minus 2 minus the square root of x plus 4 equals 0. This equation contains two radicals. So there are steps we're going to use to solve radical equations that contain one radical, and steps we'll use to solve equations that contain two radicals. Now, when there's two radicals in other terms, there is also another way we need to do that. That's a step we have to add. But for right now, we're going to start here. All right, let's get some steps down. Step 1. Isolate the radical. Isolate the radical and identify the index. All right, we're going to use algebra to get that radical by itself, and then we're going to find out what the index is. Rule 2. Raise both sides to the power of the index. All right, let me explain. If you have a problem and you got down to the part where you have the radical on one side and everything else on the other side, for instance, this is the cube root of, let's say, g is equal to 2. All right, you got it down to radical on one side, everybody else on the other side. In order to the opposite, all right, of a radical is a power. Just like the opposite of -3 is a positive 2, or the reciprocal of 5 is 1 over 5. The way you remove a radical is with a power. So if that's the cube root, the way I could counter that cube root is by multiplying it by its exponent. Whatever you, because it's equal sign, whatever you do on one side, you do to the other side. All right. The way you cancel out a radical is with its power. Look at the index. If that's a cube root, you take it to the cube power, or a third root, take it to the third power. Then you do that on both sides. Think about it like this. When you raise a radical to a power, this is what it looks like. What's a cube root in there? All right. So we said to the third power. That's g times g times g. Remember, whenever you have 3 of something, for this index, 3 of something, that something comes out. So we have 3 g's under the radical. That means a g comes out. All right, with nothing left in. Then we just 2 times 2 times 2 is 8 on this side. Let's do it again. Let's say you had let's say it was 3 equals p, and let's do the 4th root. Now we need to cancel out this radical. The only way you cancel out a radical is raise it to the power of the index, and whatever you do to one side, you do to the other side. So we need to raise this side to the 4th power and this side to the 4th power. All right, remember the index and the exponent will cancel out. They're the same. So just cancel them out. Only thing you're left with is p, and 3 times 3 times 3 times 3 is 81. All right, let's keep going. Step 3. Step 3 states that we should use algebra to isolate the variable. Use algebra to isolate the variable. And then rule 4. Check the solution. Well, you got to check the answer. You have to get rid of any extraneous solutions. These are solutions that fall outside of the equation. So, well, I'm sorry. These are solutions that do not satisfy the equation. Now, if your index is even, what I mean by that? 2, 4, 6, 8, ... and 0. All right. So, well, ends in 0. If your index is even, you may have solutions that do not satisfy the equation. So you have to check. All right. Let's practice. Let's see what we got. Let's put all this stuff together. Let's try that equation we had up here. So we have the square root of 5 minus x minus 3 equals 0. All right. First things first. Isolate the radical. Cool. We have the radical and a constant. To remove the constant, you have to add its opposite. So we add 3 on both sides. Remember, we never stop doing solving equations. We have not stopped. The radical then comes down. 5 minus x. 3's cancel. Equals 3. Now, your radical has been isolated. Identify your index. Index is 2. We need to get rid of this root by multiplying both sides by the power of the index. Well, if the index is 2, we're going to multiply both sides by exponent of 2. Or we're going to raise both sides to the power of 2. This 2 will cancel out that 2. Only thing that's left is 5 minus x. On this side, 3 times 3 is 9. Now we get the variable by itself. So we subtract 5 on both sides, move that constant term, and we're left with negative x. Remember, you cancel the 5, the negative x come down, equals 4. Now we got to get rid of that negative x. Well, there's a 1 there. So we divide both sides by negative 1. And we're left with x is equal to negative 4. Now, we need to find out if this is an extraneous solution, or or does it satisfy the equation. Let's see. Well, plug that negative 4 into your original equation. So the square root of 5 minus negative 4 equals 0. I'm sorry, minus 3 equals 0. All right. Remember, the two dashes cancel out. You end up with 5 plus 4 minus 3 equals 0. 5 plus 4 is 9. So the square root of 9 minus 3 should equal 0 if this solution fits this equation. The square root of 9, that's 3 times 3, right? A 3 comes out. So that's 3 minus 3. It should equal 0. What's 3 minus 3? 0. And 0 does equal 0. So this is not extraneous. This is a solution. It satisfies the equation. All right. Let's do another one. Let's say we have 4 square root of y minus 6 equal 18. All right, so we have to isolate the radical, right? Well, you have a coefficient and a constant. Oh, and in that case, you always move your constant first. Coefficients always last. So we end up with 4 square root of y equals 18 and 6 is 24. Now we divide both sides by 4 to isolate that radical. And we end up with square root of y is equal to 6. Now, to remove that radical, we raise both sides to the power of the index. So we raise both sides to the second power because that's the index. The index and the power cancel out. We're left with y is equal to what's 6 times 6? 36. All right, let's see if that satisfies the equation. 4 square root y. Oh, sorry. 4 square root of 36 minus 6 equal 18. All right. So let's do it. Let's fix the simplify the radical first. But 36 is, come on now. 36 is 6 times 6. Well, I have two things. A 6 will come out to join that 4, which leaves us with 24 minus 6 equal 18. Does 24 minus 6 equal 18? It sure does. So this solution it satisfies the equation. Let's do one where it does not. 2t plus 15 equals t. All right. So the good news is that the radical is already by itself. So to isolate, to remove the radical, let's raise both sides to the second power because that's the second index. Two index. So this index cancels out the power. So we just left with 2t plus 15 equals t times t squared. Now we have a quadratic. That means we get everything to the same side. I like my a term positive, so we're going to move this 2t over here and the 15 over here. So we'll do one at a time. Subtract 2t on both sides. We end up with 15 equals t squared minus 2t. All right. Then we'll subtract 15 from both sides. Still don't have any like terms on that right side. We end up with 0 is equal to t squared minus 2t minus 15. You thought this factoring thing was over with, didn't you? All right. Because our a term is 1, we just go ahead and put it on the cross. Remember, your c term goes here and your b term goes here. You can make a 4-term poly, or you can just get your 2 parentheses. All right. Now, 15 is negative. Well, say we're trying to get negative 15. So negative 15 times 1 we can do 5 times 3. The sign of your B is the sign of your biggest number. All right. So which one of these factors that multiply to give us negative 15 also combines to give us negative 2? The negative 5 and the 3. So we have t, use the variable t minus 5 and t plus 3 equals 0. Well, remember, how do we get, what's the next step? We have to find the solutions, right? So we say set each factor equal to 0. We add 5 to both sides for this first one, and we have our first solution is 5. Our next one, subtract 3 on both sides, and we have t is equal to negative 3. One of these will not satisfy. All right. Square root of 2t plus 15 equals t. We're trying to find out if 5 and negative 3 are both solutions. Let's see. We got to check both. First, we're going to plug in 5. So the square root of 2 times 5 plus 15 equals 5. All right. 2 times 5 is 10. 10 plus 15 is 25. So we have 25. Square root of 25 equals 5. Square root of 25 is 5 because we have 2 5s, right? So 5 equals 5. So the first one satisfies. See about the second one. We have the square root of 2 times negative 3. Plug in that negative 3 where that t is. Plus 15 equals t. Equals negative 3. Tripping. All right. What we end up having? Square root of negative 6 plus 15 is supposed to equal negative 3. Negative 16 and 15 is 9. All right, so square root of 9 is supposed to equal negative 3. It does not, because 3 times 3, 3 comes out. 3 does not equal negative 3. So 3 is extraneous. The only solution that satisfies this equation is 5. All right, I'm going to reload another video covering what happens when you have 2 radicals.